now talking about the Chrome browser. So it's a compile once, run anywhere technology, or at least on Chrome everywhere. So that includes Chrome on Windows, Mac OS X, Linux, and also Chrome OS. So what that doesn't include is Chrome on iOS and Chrome on Android. Those are special, hence the star on the arrow there. So I'll start out by talking a little bit about the project. This has been kind of a side project for me for a long time. So, and we are now finally getting it into a usable state. I'll speak a bit about native client itself, the technology. I'll show you how to use Qt on native client, how to configure it, compile it, set it up, and so on. I'll talk a bit about porting Qt applications, what you need to do for your applications. And then we'll have one last thing at the end. So I've always wanted to do a one last thing, so we'll see how it goes. Before we get started, have any of you used native client before? Or just one? Okay, yeah. So it's going to be interesting. I mean, yeah, unfamiliar territory. Yeah. So let's get started. So we have to go back to December 17th, 2009, when this video was posted on YouTube. So let's see. This is so this is the first public reference to the project that I could find. So this is actually Qt 4 and its graphics view. And it's running in Mozilla Firefox for some reason. So this was how the native client project from Google started out. It was actually a general browser plugin using the NP API. And, but that was back then. These days, it's a Chrome technology built into the Chrome browser instead. Let me see if I come back. Yeah, so I got 5,000 views and 1 like for my video. So that's so thank you, whoever that was. I don't think it was me. Okay, so then what happened? Then we started, I was sidetracked. We started doing Qt 5. So that was a rewrite of the platform plugins. So I spent some time on that. There was some organizational changes. We focused on the one platform, or the 2 platforms, instead of all the platforms for a while. And also, Qt went in a direction with Qt using OpenGL. So back then, there was no WebGL, so that made it difficult. Also, it started using the V8 JavaScript engine. And the problem with that was that V8 doesn't have an interpreter. So porting to native client is hard. Today, Qt uses V4, the built-in JavaScript engine, which has an interpreter. So that's no longer a problem. And WebGL is everywhere. So these days, things are looking better, and we can actually get to some actual working applications. So the benefits of Qt on native client, as I see them, I mean, why should we try this? Why should we bother? Is that we can get to kind of having 0 deployment applications. So you can upload your application to some server somewhere, and then the user can run your application immediately. So there's no App Store approval step. There's no install step on the user side. We also have application sandboxing. So that means the user doesn't have to trust the application. So that lowers the barrier to entry. So that can be viewed as an advantage. Of course, sandboxing has some additional challenges since you don't have complete access to the operating system. So There's a limitation to what your application can do. And with Qt, we want to make it so that it's run recompile away. So you can use your existing code base and then recompile for native client and deploy your application. We're not there yet, but I'm trying to get as close as possible to that state. So availability, this is a tech preview. You can get source code from Qt.io, from code.qt.io. So there's a branch there on the Qt-based repository. And it contains a README file with instructions for getting started. So in the fine print, this is not included in any release, and it's not officially supported. So when I say we support this and that means that I support it, but the Qt company doesn't support it, so there's no guarantees. OK, so let's try a demo. So let's see. This should be usable. Yeah, let me close now that one. And my display things. Yes. So this is what you would be distributing when you have a compiled application for native client. There's some HTML files here, JavaScript. This is the binary itself. And I'll get back to what these files are in a little while. So we can look at, it's interesting to look at the size. So we are around, OK, sorry. Yeah. So it's a 35 megabyte binary, which is pretty large, but it compresses well. So oops, it would. Well, so it compresses down to around 8-10 megabytes. So that's kind of reasonable for a Qt application, even for distributing it over the web. So let's put up a server. So this is just a standard web server. You can serve this on any web server because there are no server-side components or no active server-side components. And we start up Chrome. And there it is, shader effect example. This is OpenGL interactive example. And so the way this works is that it is embedded in the web page as a container. So there's an embed tag here. So the application becomes a part of the web page, and it's displayed wherever you place this embed tag in the page. OK, that was shader effects. I'll stop the server, and let's go back to the presentation. OK, so that was the intro. Now I'll spend a few minutes talking about native client itself, the technology from Google. And I'll try to keep it brief and just go over the main points. So native client is a sandbox for native binaries. So the binaries that it runs are x86 and ARM binaries. They are not any x86 and ARM binaries. They are compiled with a special compiler that is a part of the SDK. And then portable native client is an abstraction on top of this, which offers an architecture-independent format. So this gives us the ability to distribute a single binary, which then can be compiled or translated down to a native binary on the client or in the browser. And then there's an SDK, which we use as developers for when developing applications for native client. So the SDK is versioned like Chrome. There's a canary version. So actually, when you download the SDK, you get an updater script, and you run the updater script, and it will download the stable version. This could be Pepper 40, for example. So I think there's a new update every 6 weeks, same update cycle as Chrome has. And so the SDK provides several toolchains. So there's so the top one here is the portable native client toolchain. And then there are several native client toolchains, and these target a specific CPU architecture. The Mac in front there, that's the host. So the binaries that the SDK produces are not tied to any specific operating system. So we have a compiler, and there's also an API you can use, the Pepper API or PP API. And that API is a cross-platform C and C+ API, which provides us with graphics context, input events, keyboard mouse events, some networking support, and so on. Yeah. Okay, so on to the interesting part, at least, I think. That's using Qt with native client. So it is similar to using Qt for any other platform. You configure and build Qt, you build the application, and then you deploy your application. So we'll take a look at each of these steps now, and I'll show you how it works. So configuring Qt. There's a native client configure script, which will set up the Qt build for you. So you pass one of the toolchains, either the portable native client toolchain or one of the native client toolchains. And the reason for using one of the native client toolchains is that they can be easier to work with. They are faster. You avoid the translation step from that the portable native client toolchain has. And we support, I currently support Mac OS X and Linux as a host system. There's unfortunately no Windows support as a host at this point. But as a target, Windows is supported. So Chrome on Windows can run the binaries. So we build Qt like we usually do. So this is the supported module set. So the ones I try to keep, or the ones I keep building. So you can use Qt base, that's widgets and graphics view. You can use declarative or Qt quick controls. So other modules might work, but then you're kind of on your own. So that's untested territory. So when you build the application, you will get the binary, which is either if you're using portable native client, that's a .bc file. So this is a kind of an intermediate file. Or you can get the native client binary. And the browser can't run this directly, so we need to have a deployment step. And that's next. So we need to create some supporting files. We need to create an HTML container. We need a JavaScript loader. And then there's also a manifest file. So that's a detail of the native client implementation. There's an additional step for portable native client where the BC file needs to be finalized to the portable native client executable. So the BC file is an intermediate format that is dependent on the compiler version. So it's an LLVM bitcode file. But then the PX here is the portable or the stable executable that you can ship or deploy on a web page and ship to other browsers, and ship to the browser. While we are deploying, there's also an optional step we can use as developers, and that is to enable Chrome GDB debugging support. So that means we can debug the application in the browser while we are running it. And so to help us with this, we have a tool called NaCl deploy Qt, which you run on the output for make, and it will then create these the helper files that we need. So I'd like to demo this a bit, and we'll see how a build and run cycle works. Oops. So let's take a look at the gallery example. Let me close this. So we run make. And this gives us a binary there. We can then deploy that. There, and we can run it directly, start Chrome directly and run it. Let me close Chrome first. Oh, just a minute, I need to... So let us say, yes, there it is. So these are the Qt quick controls. And here, this is the output from the server serving the files. So that's a pretty easy build run cycle. So, and this gallery works as expected. And click the buttons. It's also zoomable. So the browser zoom is supported. This build has a text issue. Anyway. Okay, so that was just deploying and running the application. And let's see if we can get debugging up and running. So for that, we're going to use the same game example. So I've built the same game here. Deploy. And we're going to pass the debug argument. So this will start Chrome and with a special, in a special debug mode. And Chrome will then stop before starting the application, which will allow us to connect with a debugger. So let's see if it works. Chrome is closed. OK. So this is Chrome stopped. This is the debugger window. I can make that a bit larger. And then I have some help here. So let's see, is that visible? Yes. So you connect to it. And the process is still stopped somewhere. We can then, for example, set a breakpoint. Yeah, that's good. And we can continue. And we can now step through the application as it loads in the browser and get back traces. So it will also catch crashes like the debug does. So, and this example actually has a bug, so let's see if we can get it to crash. It usually does. So yes, for once I wanted it to crash. So. And there it is. There's some sort of memory corruption going on. Yeah. So I won't debug that further now. You can save that for later. Let me clean up. So that was deployment and debugging. So as a next step, let's have a closer look at some of the files. And I'll just go briefly over the structure of the deployment files here. Because this, what NaCl deploy Qt produces is a kind of a template or a starting point. So you might want to customize this if you're doing your own deployment. So in index.html, it's actually quite simple. There's in the body of the HTML, you have a container div, and you give it that name, and you load the Qt loader script, and you then create a Qt object. You pass it the manifest file, application NMF, and specify the type. And you then ask Qt to create an element for you, which you can append somewhere in your HTML structure. Finally, you call Qt load to start loading. And if you want to delay loading for some reason, you can call that at a later point in time. The manifest file is not that interesting. It's basically boilerplate code, and it points native client to the actual application binary. So this is a simple setup. You can have more than one binary, I think. You can ship if you have a specialized x86 binary, you can ship that alongside the portable one. Okay, so let's take a look at another demo, and this time it's the Qt Quick Playground. So let's see, I think I'll just open up a server. Yeah. Let me, like so, I think. Okay. So the Qt Quick the Qt Quick Playground has a QML editing field over here, and then a Qt Quick preview on the other side. So this is live. I can add text. Let's see. Set a color. How do we do this? Font, point size. Yeah. Let's try a rotation. Yeah, that worked. Duration, yeah. So this is a live preview, as I said. So there's some interesting features here. We can create a gist from this code here, and it goes on GitHub. And you can also share. So it's possible to share. I mean, when you create a gist, you get this ID, and then if you start the playground and pass it that ID, it will load that gist from GitHub. So this is not online yet, but perhaps it could be some kind of a code paster for Qt or for QML. Yes, I have some gallery example with images and so on. So that was the playground. Okay, so behind the scenes, the playground is powered by a Qt runtime. And the idea behind the runtime is that if you're only working with QML and Qt, then we don't need to compile C++ code. So we can compile a Qt executable, and that's shipped that to users. And users can be other developers and perhaps end users. And so the idea here is that we can lower the barrier to entry for Qt, at least for QML and Qt, and the users can avoid installing the SDK and so on. So there's an API, QtQuick.js, where you create a Qt object. You set the source, the QML source, and then you create an element and append that in your HTML somewhere, as before. And the set source is it's a live QML thing, so if you set the source again, the view updates with the new QML. Okay, so that was the Qt offering, or the Qt setup for native client. So next, I'd like to talk a little bit about porting applications. What you have to do, or what you can do with your applications to make them run on native client with Qt. So there are 3 areas here. It's the application environment. I'll talk a little bit about what's available, what's not, from Qt and from the system. Application startup is a topic where there's some porting required. And then we'll take a look at security and actually look at security failure, what that looks like if you create a binary that the browser will reject. So the application environment, 2D and 3D graphics are available. So widgets works, graphics view works, OpenGL works. So it's an OpenGL ES2 variant, WebGL, and Qt in general is available. There's a platform define that we can use if you need to write platform-specific code. Qthread is available. QProcess isn't. So it's a single process, but you can have multiple threads. Networking using QNetwork Access Manager is available, but it's running under the web security sandbox. So you can't open a network connection to any server. You can talk back to the same host where you're hosting the application. And this includes XML HTTP request from QML. Okay, so application startup. And the problem here is that, so this is the standard application startup, where we create a GUI application, we create a root application window, then we call app exec. And so the application lives inside app exec and doesn't return until we quit the application. And the problem here is that the startup call from the browser is a callback, which we have to return from. So the case here is slightly different. We can't take and hold the main thread. We have to return control to the browser. So we need a new API. At least that's the current solution we have in the native client branch. So that's a macro, Qt main. It takes an init function and an exit function. And this gives Qt control over application startup. So the way we port the other example of this is that we, instead of constructing the application window on the stack, we construct it on the heap in an application init function. We then make sure to clean up after us on exit. And then register the functions with the Qt main macro. And you may see that what's missing here is creating the Qt application itself. So that's now taken over by Qt. So Qt manages the Qt application object. So Qt main gives you a Qt application, and then there are Qt Widgets main and Qt core main as well, if you're using widgets, for example. Yeah. So this isn't in the mainline Qt, it's in the native client branch. So of course, having a special API there is not ideal, but it's the solution we have for now. Okay, so security. So the binaries you run are verified at startup when you load the binary in the browser. And what's interesting is that the compiler may actually produce unsafe binaries. And we can make it do so if we want. Of course, there's no point. But so the compiler is not a part of the security in that way. We don't have to trust the compiler. Because Chrome will verify and make sure that the binary is safe when loading it. So when you're working with native client, you might run into the situation that you get a safety verification failure. So what does that look like? Let's see. So this is the output from Chrome in such a case. And we see that the error here is error while loading shared libraries, Qt GUI. Failed to load code from shared object, invalid argument. So it's kind of opaque. And then there's process exited. So yes, this didn't go as expected. But what we can do then, we can run the validator on the host. And there's an ncval tool. So we run it on libqtGUI. And it will tell us that yes, libqtGUI is in fact unsafe. And it will show, or it will give us the location of the issues. So we see there are illegal and undefined instructions at so-and-so address or location in the binary. So the next step is then to disassemble. And we grep for the location in question. And this gives us two things. It gives us a function name and the actual instruction. And so the error here is that we were trying to compile Qt using AVX vector instructions, which is not supported by native client. And so the fix is to use some other conversion function in this case. So we would fall back to the non-vectorized conversion function. So this shows you how to debug verification errors. So you run the validator, you disassemble, you look for any clues in the code to what it might be, and you then patch the source code and try again. Okay, time-wise. Yep, so there's time for one last thing, which is mscripten. So mscripten is a completely separate project from native client. It's a compiler that compiles C++ to JavaScript. And so you have your CPP file, you compile it, and you get a .js file which you can then run, for example, under Node.js or in a browser. And of course, we have to try to make Qt run in a browser using mscripten. It's too tempting to not do that. So what we are trying to do is to use the same code base it on the native client, Qt for native client code base, even though mscripten is completely separate. So we add, for example, we add a target to native client configurer. There's a sub OS defined, so we treat it as a variant of native client. And we even try to keep the platform plugin, or we try reusing, or we try to keep using the Pepper API. We are something called Pepper.js, and Pepper.js is a separate external product on GitHub, which is a re-implementation of the Pepper API on top of JavaScript and HTML5. And then we make native client deploy Qt and Qt loader work with mscripten output. So if all goes according to plan, then we are now at October 7, and Qt runs on Firefox again. Hopefully, let's see. So I named this Qt logo. Yeah, so there's the index file, we have in the index HTML file, a Qt loader, and the app itself. So that's 46 megabytes of JavaScript. But this also compresses very well, so not zip. And this time I have write permission, I think, yes. That's 8 megabytes compressed. So 8 megabytes is what you would be shipping over network. So again, that's reasonable for a Qt application. Now I need to get it back. Yep. And we are in Firefox, and let's see, loading. Yes, there it is. The first application, Qt application for mscripten. So, and yes, it is a live application. It's not just a picture. So, yeah. Well, thanks. I have to say this is a bit more limited than native client. So I think this example is about the only thing that runs right now. So let's see. I think that's it. Thank you.
Okay, we have time for questions.
Can you explain how the Qt binaries and
Yes. So we are using. It's basically all static builds. So it's a static build of Qt. So we use the existing infrastructure for static builds. So I don't think there's anything particular for native client there. Oh yes, yes. Yeah, sorry. So that debugging session was from when I was investigating shared libraries and trying to make that work. So that's currently not supported, but it's something that I would like to support at some point. Yeah.
Another question related to that. So the compiler test for AVX passed, and then it built the AVX symbol, and then that didn't run in the browser.
Yeah.
So is that kind of a common problem that you have to solve case by case? That you have configure tests that are enabling features that aren't supported in the browser?
Yes, this is a problem when porting Qt. So the configure tests are made. They say, oh, okay, this looks like x86, then we can enable so and so and so on. But of course, native client is an x86 variant and a restricted one. So that's a part of the work with porting Qt. Yeah. Yes.
Another question to your last point is emscripten.
Yeah.
I didn't get the link between this NaCl and emscripten.
Okay.
Because
Yeah.
emscripten produces JavaScript code from C++.
Mm.
So why is NaCl somehow involved in that?
It is involved because I already had the native client port. So.
Yeah, but native client code is not C++, it's binary.
Yes, yes. So we don't use the native client compiler. So that's out of the picture, okay? Yeah. But we do use this Pepper.js thing. We have a platform plugin that uses the Pepper API. And I wanted to reuse that. Of course, if you would have started from scratch, then you could have developed something new. So you can say that Pepper.js is a replacement for the native client SDK. So it's implemented in pure JavaScript, which means that you can compile it with emscripten, right? So you have the Pepper API compiled with JavaScript. Then you compile Qt with emscripten to JavaScript. And then, yeah, all the possible pieces are there, you could say. And you have a JavaScript application. Was that clearer, or was it? Yeah.
Okay, let's make it clear. Emscripten really produces from C++ source code
Yeah?
JavaScript code.
Yes, that's correct. Yeah, that's correct.
And you can convert which parts of Qt already with emscripten to JavaScript?
I compile Qt Core and Qt GUI to JavaScript. So the example was just using a simple Q window and displaying raster content.
Which means Qt Widgets shouldn't also be developed by
Yeah, I tested it. It didn't work for some reason. So, but yeah. Yes. So just to be clear, the emscripten is even more experimental than native client. But it's interesting. I mean, it opens up like a cross-browser support. So, yeah. Another question? Yeah.
The sandbox JS and how that will work instead of an inscription.
ASM.js?
Yeah.
Is that question? Yes. So I think emscripten takes care of all that for us. So emscripten produces ASM.js output. So we don't have to do anything in particular. And there's also a new effort. It's the WebAssembly. You might have heard of it. That's a joint effort between the big browser vendors when producing what should you call it? Native code for the web. And I think as long as we are using mscripten, that will also be abstracted away from the users, from us.
Any other question?
Okay.
No? Okay, let's thank Morten again.